So we have this example, an introductory example. A 3 kilogram block is acted on by a 25 Newton force that acts 37 degrees with respect to the horizontal. The kinetic coefficient of friction is zero point 0.2. What is the acceleration of the block? Okay, first is we're gonna draw the block here. So this is the exploratory material of the block. And the block, according to the problem, it has a mass of 3 kilograms, or we're gonna multiply that one with 9.81 so that it's gonna become newtons. So that's 3 times 9.81, that's 29.43. 29.43, and we're gonna apply the 25 Newton force either left or right. Anyway, it's is it either left or right ang ato ang pag-apply, then acted on by the block, by a block. Okay, so say for example, since this is just an introductory, so principle lang sa atong kuhaon ani. So regardless of the direction of this block. Okay. Okay, so say we have this force, 25 Newton force, and with respect to the horizontal line, this one, so it's forming 37 degrees with respect sa horizontal, and then of course because of the action of the force, the motion will eventually be here. So this is the motion, and at the same time this is the direction of the acceleration. So that's the acceleration. Okay, so first is we're gonna look at for the reverse effective force. Since this is the direction of the acceleration, then the reverse effective force will be applied on the opposite of the acceleration. So this is the REF. And then, since this is the direction of the motion, no, padung sa right, then we're gonna have padung sa left nga frictional resisting force and the normal force. Okay, so 25 Newton force is inclined at a certain angle 37, so we're gonna get its components. So this is 25 adjacent to this 37 degree, this is cosine 37, and opposite this one is 25 sine of 37. So we can now apply for, we're gonna apply the equilibrium equation. So summation of forces vertical equal to 0. We're gonna have upward positive, downward negative. So we have the normal force plus 25 sine of 37, and then minus the 3 kilogram, which is equivalent to 29.43 newtons, and that's equal to 0. So with this, we're gonna have 29.43 minus 25 sine of 37. So this is now our normal force. That's 29.43 minus 25 sine of 37. So that's 14.384. So 14.384 newtons. And from friction, that F is just equivalent to the coefficient of friction times the normal force. And we have a coefficient of friction of 0 0.2. By the way, it's being said that it's a kinetic coefficient of friction because the body is already moving. Okay, so this is 0 0.2 times the normal force, which is 14.384, and our F is 0 0.2 times 14.384. That's 2.877. 2.877 newtons. Okay, so now we're solving for the acceleration, where in fact it's found in the REF. So we can now proceed in getting REF by having summation of forces horizontal, to the right positive and to the left negative. So what are the forces along the horizontal? You have the 25 cosine of 37 to the right positive, then minus REF, then the minus of the coefficient of, the frictional resisting force F. And that's equal to 0. So we're going to transpose this to the other side. It will become positive REF, and that's equal to 25 cosine of 37 minus F, which is 2.877. Is it 2.877? Okay. All right, so REF now is obtained. So that's 25 cosine of 37 and then minus 2.877. So that's 17.089 newtons. But what is REF? REF is equal to the weight over the gravity times the acceleration. That's why we can get the acceleration from the REF. And we are going to substitute now 17.089 for the REF. And that's equal to the weight of the block, which is 29.43. 29.43 divided by 9.81 as the gravitational acceleration and acceleration of the block. So that's going to be 17.089 times 9.81 divided by 29.43. I'm doing the cross multiply. So that is 5.696 meter per square seconds. So this is our example.